In this example, we're asked to find the determinant of a 4 by 4 matrix using as few calculations as possible. We want to calculate this as efficiently as possible. So we can choose to expand this thing along any row or any column. It's helpful to choose the row or column that includes the most zeros, because that's going to give you the fewest computations when you're finding the determinant. And so this third row is the ideal choice because it only has one non-zero entry. So I'm going to expand along the third row. Okay, which will give me, tell me that this determinant is equal to, so 3. Oh, and one thing I've skipped here. So we need to be careful with the signs. You know, we have that power of -1 associated with each term here in this cofactor expansion. We could do the -1 to the I plus j thing, or you can just remember that we alternate signs here. So the upper left corner, you always start with a plus from there, and then it alternates down the columns and across the rows. So we have a plus in that 3 position, and then since it alternates sign across the row, the signs across row 3 are going to be plus, minus, plus, minus. So we have +3. Okay, and then let me carry on here. Now I need to write the matrix where I exclude the column and the row that 3, that entry that I just wrote, belongs to. And so my first 2 rows are going to be these 2 sets of 3 entries, and then the 2, 1, 8 for my last row. So 0, 0, 4, 8, 3, -2 from row 2, and 2, 1, 8 from row 3 there. Okay, and then the other entries are all going to be 0. So sure, if I'm following these alternating signs, I have minus for the next, but then the entry is 0 times whatever matrix. It doesn't matter because we're multiplying by 0. And then same thing, I'd have plus 0 for this entry here, times whatever matrix, doesn't matter since I'm multiplying by 0, and then same thing with that last entry here. I have 0 times, who cares, because it's going to be 0 no matter what. Okay, so everything else turns out to be 0, and we just have to do 3 times now the determinant of this 3 by 3. Now here again, we can expand along any row or any column. It's helpful to expand along the row or column with the most zeros. So that would be row 1 here. So we'll expand this thing along row 1. Again, don't forget about your alternating signs here. So in the upper left, you always start with a plus, and then just alternate signs from there. All right, so this is equal to 3. That's the 3 that I had out front to begin with. Times, now if I go along row 1, I have 0 times, well, okay, and one of the main themes here is it doesn't matter. If you're multiplying by 0, you don't even need to find the 2 by 2 matrix. And then I have -0 times, again, doesn't matter what the matrix is here. And then I have +4 times, okay, so this is a non-zero entry here. So I need to actually figure out what 2 by 2 I have left over. When I delete row 1 and column 3, which 4 belong to, I have this 2 by 2 matrix. Okay, so this determinant is equal to 3. This is 0, 0 plus 4. So 3 times 4 times the determinant of this 2 by 2. So here we just do 8 times 1, so 8, minus 2 times 3, so 6. So this is 3 times 4, which is 12, times 2, the determinant is 24.